This is worksheet 8.1, practice going grams to moles to atoms and atoms to moles to grams. Some things you might want to have on hand to do this worksheet is this reference sheet that you'll get on a test. You'll want to look at the mole conversion part, and we go grams to moles to atoms or atoms to moles to grams. We always have to go through moles. You can't go from grams to atoms or atoms to grams without going through moles. Moles is the equalizer. Something else you might need is on this sheet, you might need the unit conversions. And as always, you will need a periodic table. So here we go. What is Avogadro's number? Avogadro's number is 6.022 times 10 to the 23rd. And how do you enter that into your calculator? You have to know how to use scientific notation or you will not do well on your test. So you need to have a scientific calculator and you need to be able to know how to use it. So in your calculator, notice that lovely bright ring of a light. You will go 6.02, a little too many dots there, 6.022, and to get to scientific notation, you're going to hit the second button, and then you're going to hit the comma button, and you want to access that EE. That second button is gold because you're accessing that EE function, and that will plug a capital E into your calculator. You can write that E as a lowercase e on paper, that's fine, and then you plug in 23. That is how you get scientific notation. If you plug in 6.022, the times sign in 10, and then caret 23, you won't always get the right answer because you have to know how to use parentheses. So let's move on to the next question. The next question says, write the mass and the amount of atoms for each of the following given the amount of moles. So the very first one says 1 mole of lithium. So 1 mole of lithium, go to your periodic table. And the mass on the periodic table, this mass here at the bottom of lithium represents 1 mole of lithium. So 1 mole of lithium is 6.941 grams. Now, how many atoms is that? You just have to memorize that a mole is 6.022 times 10 to the 23rd atoms. And now we'll keep moving along here. So 1 mole of B, which is boron. You have to hunt and peck on the periodic table and find boron. And boron is 10.81 grams. And it is the same number of atoms. They have different masses, but it's the same number of atoms in that grouping. The next one's a little bit trickier. It says 2 moles of hydrogen. So that means you will find the mass of hydrogen on the periodic table, and it's 1.008, and you'll multiply it by 2. So you'll go 1.008 times 2, which equals 2.016 grams. And then you will do that for the moles, or the atoms. You'll multiply 2 times Avogadro's number to get, now let me show you how you plug this into your calculator one more time. So I already have Avogadro's number typed in there, and I'm going to multiply it by 2. And it looks like it's 1.20. Notice E, that means times 10, and then 24. So always look clear to the right. So 1.20 times 10 to the 24th atoms. And then 3 moles of magnesium. That means we're going to go 3 times whatever magnesium is. And magnesium is 24.31. So 3 times 24.31. So 3 times 24.31 is 72.93 grams. And again, we multiply by 3 because there's a 3 there. Now, how many atoms is that? So instead of multiplying by 2, we're going to go 3 times Avogadro's number. It's really getting blurry there, isn't it? And in my calculator, I will go 3 times 6.022, second, hit that button with the EE in it, 23, and it looks like it's 1.81 times 10 to the 24th, 1.81 times 10 to the 24th. atoms. Next question. It says, there are blank zinc atoms present in 65.38 grams of zinc. This is kind of a trick question, but what you do then is you go and find zinc, and there's zinc, and zinc is 65.38 grams. So your brain should go, oh, if that's the mass of zinc on the periodic table, that represents 1 mole, and I know that 1 mole represents Avogadro's number, and Avogadro's number is 6.022 times 10 to the 23rd. And I'm just going to write E in there, a little shortcut. Now, question 4, we're going to use the atomic masses from the periodic table to calculate the moles of the following. So I can write railroad tracks, or I can write little fractions. And I'll do a little bit of both so you can see both ways. So we could take 68.78 grams of fluorine, and to get from grams to moles, again, we could go back to this chart. We are just going from grams to moles, and so that means given grams, we would write that up there. We multiply by 1 mole, and then we divide by grams. That grams is from the periodic table of the elements, the PTE. So 1 mole of fluorine has so many grams. So I go to the periodic table, and it says 18.998 grams. And we hit equals. This is really over 1. So this number's on top, that number's on the bottom. And when you have a number on top of the fraction and the bottom of the fraction, you divide it. I'm going to cancel out my units, and I'm left with moles, which is what I wanted. So in my calculator, I'm going to go 68.78 divided by 18.998, and that equals 3.62, and I need 4 sig figs, so it's going to be 3.620. So 3.620, and that's going to be moles of fluorine, and I'm going to put a little geometric shape around that. And how did I know how many sig figs? So that's 1 sig fig, 2, 3, 4. I know there's 4 sig figs because my number started with 1, 2, 3, 4 digits. The number of digits you start with is the number of digits you end with. My cat, he just came back from the doctor today. He was injected with radioactive iodine. He's a little cranky. He's not happy. So the next question says, convert 404.2 milligrams of mercury to moles. This one has an extra additional step. So we're going to go 404.2 milligrams of mercury. I'm going to do railroad tracks on this one. And we have to go from milligrams to grams. And to go from milligrams to grams, I'm going to pull out this sheet, and I'm going to find myself milli. There's milli. There's 1,000 millis, and we're using gram units, equals 1 base unit. So 1,000 milligrams equals 1 gram. So the gram was 1 and milli was 1,000. It's like a millennium. So your milligrams are going to cancel. And then we'll do what we did up here. On the top, we'll put mole, and it's mercury. And so far, the number associated with the mole is always 1. And then we'll find the grams of mercury, and we'll hunt and peck that on the periodic table, and it is 200.6. And then in my calculator, I'll do 404.2. I will divide by 1,000. I'll hit enter. And this number's still on the bottom, so I'll divide by 200.6 and hit enter. Since that one is 1 and that one is 1, anytime you multiply or divide by 1, it doesn't impact the number, so I'm just ignoring those like I'm trying to ignore my cat. And I love to cancel my units, so I'm going to cancel the grams and the grams. I'm left with moles, which is what I wanted. And the number is 0.002015 moles of mercury. Mercury is Hg, mercury, that's the way it ought to be. I should have been a chemistry cheerleader. So I started with 4 sig figs, 1, 2, 3, 4. I have to end with 4 sig figs, 1, 2, 3, 4. Those zeros are leading zeros, they don't count. Let's move on to the next one. This next one, you're given moles and you're trying to go to grams. I'm going to take a little shortcut here. And no, I'm not going to take a shortcut. 0.272 moles. So this time, I'll use a little fraction there. We are going to get rid of moles. So when you want to get rid of something, you cross cancel it, you put it on the bottom, and we're going to go to grams. So it's as if we were here at the moles and we want to go to grams. So this is the fraction. So 1 mole is on the bottom, and then the mass from the periodic table is on the top. And we are talking about lithium. So I'm going to write lithium there so I know to go to the periodic table. That one is 1. Lithium is 6.941. I have that one memorized. And since these two are next to each other, we'll multiply them together. I started with 1, 2, 3 sig figs. We should end with 3 sig figs. And it's 1.89 grams of lithium. And then we put a geometric shape. There we go, around our answer. This next one is a wonky looking number. If you didn't want to have it in scientific notation, you could move the decimal over 3 parts. 1, 2, 3, so we'll have a 0 at the end, so it'll be 4070 moles of Fe. Fe is iron. And then I'll do this one as a railroad track. It's just a one-stepper, so 1 mole of Fe has so many grams. I go to my periodic table, and my periodic table says 5,585 grams. So again, where on the periodic table did I find that? I found iron, and it's that number at the bottom. And then I just hit my apparatus, and it looks like we're having an earthquake. So you do 4070 times 5.85, and you get a ginormous number. 227,000. 1, 2, 3. We could put a comma there. And if you had to put in scientific notation, look at this. I'm going to go scientific notation arrow. 2.27 times 10 to the 1, 2, 3, 4, 5, 10 to the 5th. And we call that grams, and it's, I can't show you this all, iron. There we go. So you could do either way. I think when you do it in WebAssign, it may want it in scientific notation. Note that this assignment is very similar to the WebAssign you'll have in the future. Question 6 says calculate the number of atoms. So here we have moles, and we're going to go to atoms. So we're in the middle with moles, and we're going to go to atoms. So we're really just going to multiply by Avogadro's number. But we're going to write it out so we can see the work. So we have 85.0 moles of my friend Al, which is aluminum. I'll do railroad tracks. Again, the number in the bottom of that is 1. You don't have to write that in there. And we got to get rid of moles. The number next to moles so far has always been 1. So 1 mole of aluminum has Avogadro's number worth of atoms. So we're going to cross that out, like crossing things out you don't like in your refrigerator. Cross cancel them. Get rid of that smell. And then these two numbers are next to each other, so you will multiply those two numbers. Again, you have to know how to put this into your calculator. So you will go 85 times, let's watch what I'm doing here with my fingers, 6.022. You got to hit that second button. You got to hit that EE button, and then you hit 23, and look what it looks like. And then you hit enter. Duh. And it looks like I get 5.1187 E25, and we can only have 2 sig figs because we started with 2 sig figs, so it'd be the 5 and the 1, and then the times 10 to the 25th. So 5.1 times 10 to the 25th, and that will be atoms of aluminum. Put a geometric shape around it and go booyah. The last one, moles of hydrogen to atoms. So we have 2.016 moles of hydrogen. I'll do this one a little bit different. We want to get rid of moles. So when in doubt, almost anything in chemistry and in physics, if you have a unit there and you want to get rid of it, you have a fraction and you'll write it down there. And you go, oh, I must know an equivalency between moles and atoms. And you know that on your test, you'll have this, and you'll go, oh, it's 1 mole is that many, I'm on the wrong part. 1 mole is that many atoms. It's Avogadro's number. So that one's 1, and this is Avogadro's number. And those two, again, are next to each other, so we multiply. And that is going to be 1.214 times 10 to the 24th atoms of hydrogen. Again, geometric shape. And you could go back and cross out your moles, and you're left with atoms, which is what you wanted. And I started with 1, 2, 3, 4 sig figs. So I ended with 1, 2, 3, 4 sig figs. Let's flip out. Question number 7 says, we're going to, I'm lacking vocabulary. We're going to do conversions from grams to atoms. So this is going to be what I call the full meal deal. We're going to go grams to moles to atoms. And I just remember that it's GMA, Good Morning America. So we go grams to moles to atoms. You have to go through moles. And so you could go to your little mole conversion sheet that you'll have on your test. And so you're starting here. That's your starting number. You'll multiply it by 1 mole over the mass from the periodic table, and then that lands you there. And then you'll multiply that by 1 mole. You'll divide by 1 mole on the bottom, but we ignore 1. And you'll multiply by Avogadro's number on the top. So let's do this. So we have 1.72 grams of silver. Silver's Ag. I'm going to do a railroad track, and we're going to go grams to moles. I like to actually write out my units first, and then we'll go moles to atoms, and then I like to go populate the numbers. It makes me feel special. And this is why I like to do it. It makes me feel like I'm in a factory. 1 mole and 1 mole. I know this number. If you have moles and atoms, it's Avogadro's number. And the grams, this is the only part where I have to do some work. So I'm going to write silver in there, go to my periodic table, look up silver, and silver is 107.87. 107.87. So then you have to plug this into your calculator. This one involves a little bit more work than the other ones. So I'm going to take 1.72. I'm going to ignore 1 because it doesn't impact the number. This is on top of that, so I'm going to do 1.72 divided by that. I'm going to hit enter. And then I'm going to multiply by this because that is on top. Again, you have to know how to enter this into your calculator. Learning how to enter it into your calculator on test day is not going to help you, and I will not help you. So 9.60 is what your calculator is going to say times 10 to the 21 atoms of silver. Geometric shape. Next one, moles to atoms. Aha, so if we have moles to atoms, that's just a one-stepper. That's doable. So 0.0035 moles of copper times, we want to get rid of moles. Moles is on the bottom. We want to go to atoms. And when we have that relationship, 1 mole of anything always has Avogadro's number of atoms. And they're next to each other, so we just multiply them. And we will get 2.1, I keep forgetting to show this to you, times 10 to the 21st atoms of copper. Geometric shape. And I started with 2 sig figs. Those leading zeros don't count, so I ended with 2 sig figs. This next one has a little bit of a trick in it. Again, you're going to see this in your future on a web assignment. So 1 point, got lots of things going on here, 92 kilograms of magnesium. And I am going to go all the way to atoms. So we're going to go kilograms to grams. I'm going to draw my next one. And then we'll go grams to moles. And then we'll go moles to atoms. So I like to write it out. So there's my Good Morning America. And we started outside of the grams, so we had to get to grams. And how do I know what goes on the bottom here? So what is written there is repeated diagonal down here. So that'll be kilograms. And then what is written there will be written diagonal down here. Then moles is written there, so that'll be written diagonal down in that other box. Now I go populate my numbers. I love the number 1. So those ones are 1s. My atoms, 1 mole has Avogadro's. My cat is going nuts. Atoms, that's Avogadro's number. This is magnesium. I'm going to go to the periodic table, And under magnesium, it says 24.31. And this one, I'll have to go to my conversion chart, and you will find kilo. So 1 goes with kilo, and then 1,000 goes with the other number. So we will have 1 kilo and 1,000 grams. So to do this calculation, those two are going to be multiplied by one another. Hit enter, and then you're going to divide by that number and hit enter, and then you're going to multiply by Avogadro's number and hit enter. And you again have to know how to plug that into your calculator. And it looks like you get 4.76 times 10 to the 25th atoms of magnesium. So it makes me super happy. I love to give full credit to people who write out the correct number of sig figs times 10. What the unit is atoms, and what element it's referring to. The last two. So this one is, again, like one from WebAssign. It's kind of a two-part one. You could use the answer from A to do B, or you could start all over and do B, or you could use the answer from A and do B, and then do the whole way through the calculation to check to see if you're right. All right, so we have 9.3 21 atoms of potassium, and we're trying to go to moles. So teachers love to ask on tests the reverse question. They don't often show it to you completely in class, but they love to ask it. So we have atoms and we're going to moles. So I know this looks like you're going to do your multiplication that way, but that's not it. You're going to have atoms, and then you're going to multiply it by that fraction. So on the top is 1 mole, and then on the bottom is Avogadro's number. Avogadro's everywhere. Do you think he ate so many avocados that he passed out? So that's really over 1. Sometimes I need a visual to tell me that that one's on top. So that number divided by that number is going to give us 0.015 moles of potassium. And I had 2 sig figs because I started with 2 sig figs. Now this next one, I'm going to keep the whole number that was in my calculator. Let me see what that was. So 9.3 times 10 to the 21st divided by Avogadro. The number in my calculator is 0.015. I don't know, like maybe 44. I like to start with the number in my calculator, so I'm going to write that down. And that was moles, and that was potassium. So now we're trying to go from moles to grams. So 1 mole of potassium has so many grams. That's the relationship there. Go to the periodic table of elements for that one, and it is 30.098 grams. These two are next to each other, so you multiply them, and you should get a number that's not ginormous and a number that's not super, super small. So 0.46 grams of potassium. And again, 2 sig figs because you started with 2 sig figs. I hope this helped. Helped you. You better keep it. I suggest that you keep it because it will help you with a WebAssign. Until next time.